Zach's a brilliant person to do this. Zach's the longest tenured PM at DeepMind. He's worked in the London office, where I got to spend time with him. He's worked in Mountain View office, and he works here at the moment. So he's seen this change across the board. But what's probably most exciting is he has witnessed the change in the organization and the change in what the teams are researching since pre-Transformers. So since the attention is all you need paper. So if we maybe lay the foundation, if you excuse the pun, for this evening, and maybe you can help us understand the different ways of kind of categorizing progress. And one seems to be in pre-training, post-training, and then reasoning as different axes of progress. Maybe you could help us understand what those are.
Yeah, of course. Great to be here today. Thanks for having me. I'm excited to be participating. So if we look at these three key areas, pre-training, post-training, and also like the reasoning or thinking capabilities, let's start off with pre-training. That's actually where I spend most of my time. So my core focus at DeepMind is working on product on the pre-training side of things. So pre-training is really focused on the fundamental capabilities of capturing the world's knowledge and information into the weights of the model. So here we take as much data as we can. Of course, quality does matter, so it's not just about quantity, but huge data sets. And we use these data sets to train a model to predict the next token. And this is what like the fundamental breakthrough of what we saw with Transformers is just the ability to take these huge data sets and be able to create these models that can reason, that are factual, and contain so much information. Now, an analogy I like to use is your pre-training is kind of like your model that's gotten its undergraduate degree. It's very general purpose, but then you move into your post-training side. With post-training, the focus is really on tuning the model's capabilities, the style. So when you think about things like the personality, how should it respond, these stylistic elements, that's all captured within the post-training side of things. So the way that we post-train models is usually two stages. We do a SFT, supervised fine-tuning stage, and then also an RL stage. So with SFT, we'll get high-quality examples that really teach the model on how stylistically it should respond to certain questions. Then on the RL stage, we'll use reinforcement learning because it's actually a much more efficient way to hill climb. Rather than having experts who need to write these detailed explanations on or responses to questions, you could just have, using reinforcement learning through human feedback, you could just have people choose whether they prefer one answer or the other. So it's a much easier task and allows the model to significantly improve. I like to use the analogy that your post-trained model is similar. You've gotten your undergrad degree. Now you want it to, now it's entering its first job. You're really trying to get it to work well for certain tasks. So if you entered your first job and someone asked you, summarize all my emails for me, that you'd be like, well, do you want bullet points? Do you want certain people to be highlighted at the top? You want to get a few examples. And that's really what happens in this post-training process is you give it these stylistic examples. Then thinking has really taken off in the past year or so, which is really impressive. And thinking and reasoning these thinking models and reasoning models leverage the innate capability of these models to predict the next token. So what ends up happening is at inference time, you use sort of chain of thought so that the model is writing out its steps to solve the problem. And it's really interesting to see, always in grade school, people would say, write out your process on how you think through this. And models in a similar way are doing this to think through how to solve these complex tasks. And because of the nature of how they've been trained on the pre-training side, it works unbelievably well.
And so the recent progress has been largely driven by inference time or reasoning, but actually the foundation models still seem to be scaling. So yeah. I remember Eric sharing an amazing example with me that when we saw clusters of hundreds of thousands of GPUs, usually NVIDIA chips that are incredibly expensive to run in terms of energy, like one tiny change and you'd have to rerun the process from scratch. So like as you see these models that are costing hundreds of millions of dollars, is the juice worth the squeeze? Like actually, does it make sense? Are we going to continue to see the clusters scale?
Yeah, no, I think that's a $1 million question or $1 billion question.
Trillion, if you believe Sam Altman.
Yeah, exactly. So of course, I work on the pre-training side, and I'm very bullish on pre-training. And I think that's where we have continued to see some of the biggest leaps in terms of performance. When you look at like Gemini 2.5, I think that's the model that really got Gemini on the map. And I think that's where there was this inflection point for DeepMind and Google where people were like, wow, this is a really good model. And that was a core pre-training change that we made that really boosted the quality and the performance of the model. So I think these huge jumps that we see are in pre-training performance. I think what really gets challenging is that it's incredibly expensive to test hypotheses and figure out and do these large training runs. And when you're training at this huge scale, it's incredibly difficult to debug because it's the first time something's ever been trained at that scale. So we've had situations where trying to debug and figuring out that there's like raccoons in a data center that have chewed through some wires, and that's what's causing certain cells to fail. And it's really crazy the sort of bugs that people have to work through on the pre-training side. So I think on thinking and on post-training, you can iterate a lot more quickly. So we're maybe seeing more innovation there, but I'm still very bullish on the pre-training side of things, that's where we're gonna see bigger jumps in terms of capabilities.
And in the pre-training, you can occasionally invest more time and sort of pause it so you can wind back. But actually, if you're really rushing a model to market, you might have to start all over again. And so that hundreds of millions of dollars could be a complete sunk cost.
Absolutely.
You might have to start from scratch.
Absolutely, and I think we were talking about it earlier, but seeing like the huge paychecks that Meta is paying, this is what it comes down to, is like these models are so expensive to train that having the talent and the people who know how to actually train these models makes it worth it. Because being able to debug these issues and come up with like the best architecture to optimize for these huge scales it's a big bet that you're making, and it makes it worth paying people that.
And also in research, there seems to be a taste to the way you've talked about it in the past with me. I had probably wrongly just assumed it was all science. Sometimes the way you describe it feels more like art.
Oh, yeah, completely. And I think we were talking about this earlier, but the people used to always talk about the 10x engineers. And I feel like you now start to see these 100x engineers who just have this unbelievable intuition about what will work, what won't work for the models. And it's just really impressive to see how some people are constantly coming up with innovation after innovation and after innovation internally at Google that's pushing the frontier of models forward. And it's a very creative process, and people have this innate ability, and hopefully I can have that.
You definitely are building it. I mean, you have the pattern recognition, but one of the things that's interesting is you're getting this war for talent, not just because obviously this space is it symbolizes a huge market. It's also because actually everyone's competing on the same axis for the first time in a long time. Everyone is going after foundation models, and to some extent, performance is quantifiable. Like we sometimes internally have been saying, it looks like sports and free agents in sports more than it does traditional tech. An important question seems to be, how do you figure out if a model is good?
Yeah, no, that is a very important question, because I think you're only as good as what you can measure. And new evals, benchmarks are constantly being developed, and we see instances, I think like Grok 4 just came out. This model is performing really well on some key benchmarks, like humanities last exam, but it's really only as good as what you can measure. So while it's doing really well there, maybe on the safety side, it's not doing as well. And maybe that's an area they're not spending as much time measuring, like the performance. So we spend a ton of time developing new evals, and also, of course, hill climbing on existing evals, because if you're not measuring it, then you're not going to know how you're going to perform. You're going to potentially go down a path of hill climbing on some sort of capability and regressing on another capability, and we've seen instances of this. So 2.5 Pro, when it was in preview, we pushed out a fix because it boosted the quality on coding performance, which has been a key priority. But we noticed that we ended up getting a lot of feedback from customers, complaints, that it led to some regressions in terms of like writing, just core writing capabilities. And so like one of the things that we now do is we do a lot of private testing, because yes, we have our evals. Those are super important. We can measure and hill climb on that, but sometimes it can be hard to get an intuition of like, oh, it's 2% better on this benchmark, 10% better on that benchmark. How does this really translate into how downstream users like feel the performance of this model? And this is where this sort of private testing has become super valuable.
And if you look at, say, ArcAGI 2 or Humanity's Last Exam, which in theory are assessing performance against kind of AGI criteria, and in theory they're half-blinded, so you can't train to the model too much, but you know, we keep hearing about people overfitting their model to these. Like, firstly, is it fair to say that actually you don't just kind of care about the KPIs, you become what you measure? So these companies are like overfitting, and it doesn't really correlate with success. Like actually empirically, the customers don't care.
Totally, and we've seen this time over time. I think MMLU was the benchmark that everyone was hill climbing in the beginning. That got really saturated. I think LMSys became the next thing that everyone was really fighting to climb against. And I think we saw like a perfect example where Llama put out a model that was great on LMSys, and then the model that they actually put out on open source like underperformed significantly, and people were pretty upset with like the quality of that model. And like new benchmarks are constantly being developed, like Humanity's Last Exam. I think these are great benchmarks, and I think it helps push the frontier forward. But we see this like constant pattern where something gets saturated, or maybe the benchmark is not as good as people originally anticipated, and then people move on to new ones.
And there's some existing, so these were all developed specifically to address or to test the progress. There's some existing tests, like the International Maths Olympiad, started in 1959. Teams of 6 from different countries will compete against 6 questions. And there was a real breakthrough in the last few days on that. I think OpenAI claimed gold. It looks, from everything I read, like they can claim gold because they marked their own homework. Gemini did something a bit different and actually ran with the rules and achieved a gold, which is amazing because there was no translation between models. That was all in natural language.
Yeah, so it's pretty impressive. Like last year, there was a model that DeepMind developed, Alpha Proof. And I think when you look at that model, a lot of work had to be done to translate the questions into some sort of formal proof language that can then be fed into the model. And it also computationally took days to be able to calculate or like come up with these answers. And I think it scored silver. And just within a year, we're taking the foundational models that we have, the like 2.5 Pro model, and it scored gold, which is just incredible that we've gone this far, and the pace of how quickly this technology is moving just like blows my mind every day.
And it was within 4.5 hours, which is why it can officially get the results.
And it read the prompts similar, and it didn't have to translate them into a different language, and scored incredibly well in the 4.5-hour time limit. So it's pretty spectacular to see just like, and this is what DeepMind is really working towards, is the concept of general intelligence. So rather than having to have these specified models like Alpha Proof that just works well for math problems, being able to have a general model like the Gemini 2.0 Pro series, be able to solve these problems, but then also help you with writing, and you name it, I think is really pushing towards our mission.
And you've been doing some amazing jobs of releasing lighter models. I guess one of the other places that's happened recently, and we've seen really good performance on the evals, is in open source. Like Kimi K2 from Moonshot has done really extraordinarily well on that. That's a mixture of experts models, so they're taking 1 billion parameters, but they only run it through 32 billion, sorry, 1 trillion parameters, and they only run it through 32 billion to keep it light. Like, what's your view on open source? Why haven't we seen it just completely eat up the market?
Yeah, no, I think that's a great question. So I think like we see a split happening between like the large frontier models and the small models. And I think that for small models, we've seen a lot more of open source models catching up. We can see the Quen models that are state of the art for pretty like small models that are available externally. We of course have our open source Gemma series. That's like really phenomenal. And simply put, the fact that you can distill from larger models makes it much easier to train these smaller models so that they can learn from the larger ones. But number two is that it's just cheaper and easier to iterate on the smaller scale, so people can churn through a lot of different experiments and get a really good model out there. I'm pretty excited about some of these small models on the open source space, focusing on like local on-device use cases, being able to run locally on your laptop, your mobile phone, so it's fully private, doesn't have to work with connectivity. But that's very different than what you're seeing on the big model space. And I think the big model space is where you are seeing proprietary models still leading the pack. And I think what we've seen is just like there are these proprietary techniques, and it is easier to catch up, but it's much harder to leapfrog in this space. And that's what we've seen with DeepSeek and with the Kimi models. And I do feel like we might be seeing this potential transition where like the largest models and even on the llama side might be fully proprietary, and then all the open models are small. I think China is an interesting example where it's much harder for them to break into the US market, so open is a better strategy for them to get into the US market.
And you wonder, I mean, so much of the fast following is because these models can be distilled through the API.
Yeah.
A lot of companies seem to be going more full stack, partly because it opens up RLHF and the end customer relationship. But I imagine that's also because it makes it a lot harder to distill the model. So it's playing defense in a new way and stopping this fast follow.
Yeah, definitely. I think that's always a risk. We're constantly thinking about how potential competitors could take distill our models, use it to train similar competitive models. And it's something that we've been thinking about from like day one, and it's really hard to mitigate that. So it's top of mind, and we're always thinking about like new strategies.
Makes sense. Yeah. And as we sort of transition, so shortly Eric will spend some time with Zach from Warp. Like, we're clearly very interested in investing at the application layer. So one of the things that the team did an amazing job is thinking through what are the applications where the technology is soon to be good enough or is good enough today. So we thought law and invested in Harvey and LawHive. We thought coding, and Eric led an investment in Bolt.new, actually, which preceded a lot of that. Medical triage is interesting. We invested in open evidence. Like, as you look at the sort of demand from in the market, where are the areas that you feel the most pull for the models?
Yeah, no, great question. So I think you definitely hit a lot of the key ones. I think, first and foremost, like coding saw like really clear product market fit. I think some of the ones that you didn't mention that I think we're seeing very strong pull. Number one, gaming is a huge area. Developing NPCs, characters in games that leverage AI, especially because these models are getting better at multimodal input, so taking voice input, and also multimodal generation, so being able to generate voice output. So a lot of breakthroughs happening in the gaming industry. I think we're going to see a lot of neat games that are being developed. I think another really interesting one is in the financial services. So I think probably a lot of people have seen, but Anthropic recently came out with their new financial services product. And I must say, Anthropic does a really good job of focusing. And I think they went all in on code, and this is like the next vertical that they're going to be focusing on. And I'm excited to see the outcome there. But I think like being able to work well on various analytical tasks, working with spreadsheets, financial modeling, a lot of similarities with coding.
Yeah.
So I think it's a natural fit. And then I'd say another area is, let's call it like the field of research. So you see with like these deep research models, the ability to retrieve information and synthesize some sort of analysis. A lot of, when you think of consulting roles, even finance roles, that's what a lot of people are doing, is looking across a breadth of data and information and trying to synthesize some sort of research report. So I think these sort of research tasks and industries that focus on that, I think is another really prime area for AI.
Makes sense.
Yeah.
And then in each of those, do you expect to see what we've seen to some extent with coding, which is you're almost moving from level 1 to 5 autonomy, to use the example of autonomous vehicles. So you start as a co-pilot, it's assistive, it might be inside the IDE, or it may be actually for someone that has no coding experience and slightly more agentic. Like, do you imagine that path for all of these different verticals?
It's hard to predict. Exactly as you mentioned, I feel like you see much more delegation happening, and I think everyone 2025 was talking about agents and the world of agents. And when I think about agents, it's largely about being able to delegate tasks to models. And I think we're starting to see that happen in coding, using tools like Claude Code or Gemini CLI. And agentic coding tools. I think we're seeing that with deep research, where you delegate tasks to Gemini, and it can come back to you after minutes with a response. Also on like the UI computer control side with projects like Mariner. So I think we're seeing this trend towards a lot more delegation. I'm excited and we saw that happen with code. And I think like we're also, like with financial products, like you've seen with Workspace, they have a sidebar with Gemini integrated, and I hate to say, but I don't find it that useful, and I think a lot of people feel the same way. And I think that's where it's like people are integrating these tools into just like existing workflows, but what you see with these like fully automated systems is kind of leapfrogging these just like more incremental sort of improvements. So I think we're going to see a lot more of that, where these agents are developed, where you can delegate more complex tasks.
It's cool to hear. It's also cool to observe that you started angel investing a couple of years ago, and a lot of your thesis you had then is sort of playing out. It's really amazing to see. If we switch now maybe to be more forward-looking, there's all sorts of new model developments, like the MOR, the mixture of recursions model, which was a paper that Google announced last week. It was received quite well, I think. How much time is being spent on researching these completely new approaches or relatively novel approaches?
Yeah, so tons of time. So like when we look at DeepMind, there's a few core teams. So we have like our core Gen AI team, but then we also have a foundational research team. So DeepMind's roots are in this research culture, and we want to make sure that we continue that sort of evergreen research that is true to DeepMind, continuing to publish. So we have a large team that's continuing to do this foundational research. And then, of course, within Gen AI, there's a ton of research efforts. It is a research project fundamentally. So a lot of innovations are coming with the paper that you highlighted. That's like a great example, but there's tons of improvements that are constantly being made in terms of making the model more efficient for inference and also for training. It's just like we're not publishing them. So that's there's so many improvements that are happening all the time.
And it's extraordinary to have Demis Hassabis at the sort of head of this
for sure.
organization conducting the orchestra. There can't be many people, it must be sort of, you could count them on one hand on the planet that could do such an amazing job of that. Kind of going forward, anything else that we should be keeping an eye on?
Yeah, so I'm pretty excited. I think I'm pretty excited about what's happening in like the diffusion space, especially you see on the video generation side. VO's been going viral as ever. VO is a separate video generation model. It's not yet included in as part of like the mainline Gemini model, and we're seeing a lot of improvements happening there. But we've also seen some pretty neat effects with or impact of like Gemini diffusion, which is a text diffusion model. So this was an experimental model that we put out at Google I/O. Extremely fast inference, also allows for some new capabilities like inline editing. So we got like a lot of great feedback, and we're bringing that into like the model development on our side, see how we could incorporate some of those techniques to make Gemini better.
Amazing. And so you've got, I love this, the point you make about sort of the local maxima, and you're hill climbing on some of these.
Yeah.
But sometimes people sort of describe the frontier as a jagged edge. The models are getting much smarter at some stuff while they get dumber at others. Like, what are some areas that actually are the biggest gaps that maybe founders in the room can have in the back of their mind? What are the areas that you think the models just still need to get so much smarter for a breakthrough?
Oh man, great question. So I think I think like one of the key areas that we need to really improve on, and we get a lot of feedback on, is hallucination. This has been a problem from day zero. It's something that we're continuing to try to work on, and making sure that the model is like is factual and grounded when you want it to be. I think you see this continuum where there's kind of trade-off between factuality and creativity, and that's something that's kind of difficult to balance, because the more factual something is, oftentimes that leads to a trade-off where maybe it's not as creative.
Yeah.
Similar to like humans who tell stories and like to embellish, and models do a similar thing. So I think hallucination is a key area. I'm pretty excited about, I think there's we need to keep pushing the frontier forward with these, computer control and UI operation. So with projects like Mariner, and then OpenAI has like a operator product. They just came out with a new thing, I think last week, with the agentic mode. Computer control, not there yet, but like the pace is moving so quick that a few months ago, like video generation wasn't there yet either. So I'm pretty excited about that space developing and maturing, and I think that's going to lead to a lot more of these agentic experiences where you can really delegate Gemini to complete tasks for you.
Yeah, and a common theme you've talked about a lot is this idea of actually just interpretation of intention, because as you say, in many cases, hallucination is a feature, not a bug, if you want to be creative.
Exactly.
So kind of understanding that intent. I think it's a brilliant time to maybe wrap with Zach and ask Eric and Zach to maybe join and come and sit on stage and share thoughts on kind of the more applied layer. But Zach, thank you so much.
That's great.
Hugely appreciate your time.
Thank you so much. Appreciate it. That's great.